This video focuses on some of the pieces of a standard form quadratic function. We're going to identify some pieces, the axis of symmetry, vertex, y-intercept, up and down, domain, range, shape, name. This first slide you don't need to write down. We will go through the steps together in an example. So I just want to kind of talk through it first, but you can just listen. We're going to show you a standard form polynomial, ax squared plus bx plus c. And we want you to identify the degree, the name, the shape. Does it open up or down? The axis of symmetry, the vertex, the y-intercept, and the domain and range. All right. Now this is what I do want you to write down, is everything that I write through this example. This is a very important example. So we give you a function, h of x equals x squared plus 6x plus 5. Please make sure you pause when you need to. So I'm going to first identify the pieces of the quadratic function. A equals 1, b equals 6, and c equals 5. We want to make sure it's in descending order, x squared, x, and then constant. So let's identify a few pieces of this quadratic function. Let's talk about the degree. The highest order polynomial piece is an x squared term. So we say the degree is 2. Every polynomial that has a degree of 2, its name is called a quadratic function. The shape of every quadratic function is going to look like a U. Or you can say a parabola. And then the name of this polynomial is a quadratic and there's 3 terms, 1, 2, 3, so we call it a trinomial. So that's just some general information about this polynomial. Now let's identify the degree, leading coefficient, which is our A term. So I'm just going to erase this stuff now here so I can look at it. My leading coefficient is a positive 1. Since my leading coefficient is a positive 1, this graph is going to open up. The U is going to look like this. We're not going to take the time in this lesson to graph everything. I'm not going to ask you to do that. I'll show you on this video what it kind of looks like, but in your homework, you just have to identify the pieces to this standard form problem. Step 3 is to find the axis of symmetry. Where is that line of symmetry that is symmetric? So we're going to use a formula every time. X equals negative b over 2a. Some teachers also call it opposite of b over 2a. You can say it either way. So where we get these numbers from are from up here. Here is our b, and here is our a. So we say 6 with an opposite, so it's negative 6, over 2 times a, and a is 1. Now we'll just simplify that fraction. Negative 2 over 6 is negative 3. So our axis of symmetry equation is x equals negative 3. Our line of symmetry that's vertical is that x equals negative 3. So if we imagine our coordinate plane, we would go over on the x-axis 3 units, and we would draw an imaginary line. And that's what our axis of symmetry line would look like. What we want to find next is the maximum or minimum point on the graph, which we call the vertex. So half of the vertex answer has been found. Whatever your x value is in your axis of symmetry, that is going to be your vertex x value. So it's negative 3. And then to find the y value, you just say f of negative 3. So we have to evaluate the function. So our original function was f of x equals x squared. It's going to scroll up here, plus 6x plus 5. we're going to find out what is f of negative 3. So replace the x with negative 3, replace the x with negative 3, and simplify this. So we do our orders of operations. Negative 3 times negative 3 is positive 9. 6 times negative 3 is negative 18, and then plus 5. 9 minus 18 is negative 9, plus 5 is negative 4. So this is now our y value for our vertex. So our answer then is negative 3, negative 4. There is our vertex, our maximum or minimum point on the graph. The next thing is to find the y-intercept. Where does it cross on the y-axis? That is going to be the c. So here is my c. That is your y-intercept. So down here, our y-intercept is 0c. So the answer is 0, 5. The domain and range. The domain is what type of numbers can you plug in for x? So if that is my function, is there any restrictions on its domain? Anything I cannot plug in for x? The domain will always, in a quadratic function, will always be all real numbers. For the range, that's a little bit different. So I want to just take a moment and grab a few of these things that we already found in these previous steps. Again, you don't have to do this part, but I want to explain what we just found. So y-intercept is our y-axis. We're going to go up 5 units. Here's our point, 0, 5. We then found our vertex point, negative 3, negative 4. So on the x-axis, negative 3. On our y-axis, negative 4. Here is our point, our critical point, our vertex. And then we knew that our shape of our graph opened up. So this is my minimum. It's going to go up here. It's going to go up there. I had that line of symmetry going through at x equals negative 3. So if I ask you for the range, that's your y values. If I cut across here horizontally at y equals negative 4, anything above that yellow line exists for its range. So we say then the range is y greater than or equal to negative 4. Anything above that negative 4 point. And that's how we can find the 6 steps. Now if this looks a little bit overwhelming to you, we will do these 6 steps together in a warm-up in class.